You said something about them being separate the same distance, something like distance. The distance is relative to a metric.
If the metric means that the size of this interval here, delta x, which is approximately delta x, as a vector, this is a number, some magnitude, some number of v divided by v magnitude. So if I take a unit vector here as a tangent vector, I'm cheating because to define the length of unit vector, I'm using norm in here. So this thing is, squared. It's delta x I g I j delta xj, where that's the Euclidean metric is just 1, 1, 1, but in general dynamical system there's absolutely no reason to use Euclidean metric. You have to really think about what notion of distance mean in general. This metric in general depends on where I am, but I'm not allowing time dependence of the state space itself, including the way I triangulated and measured the distances. So this will not be time dependent, just space dependent. Then the argument holds because when you come back, you're evaluating the metric at the same point. So no matter what distance you're using, it's the same distance. This j that we define is coordinate free because the j if you look at dxi, dxj, and you do any coordinate transformation, so you go to new coordinates yi, which is some nonlinear but invertible and smooth differentiable, etc. thing of x's. So if I go to new coordinate system, so I was in M, but now, German state space, but now I'm going to Japanese state space, and it's described by unique mapping of 1 to 1. Then when you work this out, and we'll do this later in this chapter, we will prove that Jacobian itself is invariant under all smooth coordinate transformations, so on the whole general covariance group. And the idea is very intuitive. Jacobian is comparing infinitesimal neighborhoods when they come back for periodic orbit, by the way. And as I apply my stretching and squashing, on periodic point, I stretch and squash, both x upstairs and downstairs by the same h function, and they cancel in linear order. They don't cancel in higher orders, and that's why it's very hard to define nonlinearity. The parabola is very hard to define in these terms. You immediately get into connections and blah, blah, blah. But the linear order is fine.